In this example, we're going to look at how to solve 2 sine 3x plus 1 equals 0. So as in the last example, we want to look at values between 0 and 360, but we want to triple the domain because we're looking at sine of 3x, so there should be 3 waves between 0 and 360. So to do that, we just multiply everything by 3, and we're looking at values between 0 and 1080, and then we'll divide back by 3 right at the end. So we'll carry on as before, take away 1 over to the other side, divide by 2, and we get negative a half. This happens in the tan quadrant because sine's negative, and the cos quadrant. So find the acute angle or the base angle, inverse sine a half, and you'll get 30. Then to find these two solutions, you go forwards from 180 and back from 360. So 3x is equal to 180 plus 30, and 3x is equal to 360 take away 30, which is 330. So this is the point where we take these two values and we jump forward 360 degrees from each one to get the same value a wave forward. We keep going till we get to 1080 or before it, but don't go past it. Now because there's 3 waves, we should have 6 solutions here, 2 for each wave. So we'll start at 210 and 330, and we'll go forwards 360 from each one. So 210 forwards 360 gives you 570, 330 plus 360 gives you 690, 570 plus 360 gives you 930, and 690 plus 360 gives you 1050. 1, 2, 3, 4, 5, 6 solutions. We then divide by 3 to get all our answers. In this example here, the difference is that we're dealing in radians. We can see the domain is between 0 and pi. The easiest way to deal with this is to change it into degrees and then change back into radians at the end. So when I'm thinking of pi radians, I'm thinking of 180 degrees. I've got a 3x here, so I want to triple up everything. So multiply everything by 3, and you want to change your domain from 0 to 540 because 180 times 3 is 540. We then carry on as normal. Now what I would do is I would take the 2 tan 3x over the other side to make it positive. So 2 tan 3x equals 2 by subtracting the 5 over. You can take longer to do that, but all I've done is taken that over the other side and subtracted the 5 here. I'm then going to divide by 2 to get tan 3x equals 1. I'm then going to look at where the tan is positive, and that would be here and here. Find your base angle or your acute angle, so inverse tan 1, and that comes to 45. So the first answer is 45 in the all quadrant, and the second answer will be 180 plus 45. So 3x equals 45, or 180 plus 45, which is 225. So take your values, 45 and 225, and because of the period of the graph is 180, you could think you jump forwards 180 every time, but if we have a wee quick look at the graph, if I've worked out this value here, which is 45 say, and I jump forward 360, then I'm going to get this solution here, which is fine. If I take this second value of 225 here and I jump forward 360, I would get the next solution. So you can just jump forward 360 degrees as before. Or you could say I've got 45, I've got 225, jump forward another 180 to get this one from the 225. In my example, I have jumped forward 360 to get 405. At this point, I'm going to change back to radians. The reason for that is when I divide some of these numbers by 3, you sometimes get decimal values. So change it to radians first and then divide by 3. So divide, multiply by pi and divide by 180 to change into radians. So multiply by pi, divide by 180 for each of the values there. Cancel it down. So pi over 4, 5 pi over 4, and 9 pi over 4. Always look for dividing by 45 because 45 goes into 184 times. 45 is a good factor of these values. And finally, divide by 3. The easiest way to divide fractions by 3 is to think of dividing by 3 over 1, which is the same as multiplying by 1 over 3. So if you're multiplying these by 1 over 3 or a third, the bottom number is really multiplied by 3. So that makes pi over 12, 5 pi over 12, and 9 pi over 12, which cancels down to 3 pi over 4.